In the last few videos, I've explained why I believe Apple has an edge in the AI race. It's because of the hardware and making it easy for developers to use this advanced technology. So in this video, I'd like to show you a real example of that using spatial photographs. But before I do that, let me cover off the basics. Most photographs you see on the internet are JPEG files. This is just a file format that was established back in the 90s to make images small enough to be used on web pages. It's a lossy format, which means that when you take a picture, the JPEG algorithm throws away some information it doesn't think you need. So the quality of the photograph decreases slightly as well. So if you've got a standard photo, where do you get the depth information from? You've got to get it from somewhere. So how? Well, that's where the AI comes in. People have developed models that take standard photographs and predict depth. They've been trained over billions of photo examples, so they can make really accurate predictions about the distance of something like a tree or a human. So in this project, I'm going to use one of these models with Apple's CoreML framework that turns 2D images into 3D images. Now for this project, I'm going to be using Apple's Xcode, running a language called Swift, which Apple developed. Unlike languages like Python, which are interpreted, Swift is compiled, which means it's stricter and requires much more discipline up front, but it runs a lot faster. I'm also going to use Claude Code, which will be writing the code for me. This is another great example of how AI is making developers much more efficient. Of course, you still need to know what you're doing, but there's no way I could have built this in under an hour without Claude Code. It's just too hard otherwise. Now, I happen to have an Apple Vision Pro, but even if you don't have one, you can still develop applications on the simulator. Xcode ships with simulators that allow you to test your applications before they get pushed to your device. I'll show you this shortly, and I'll show you the finished prototype running on my Vision Pro. So we'll start by creating a blank Xcode project. I'm going to choose a Vision Pro app template because it comes with all the basic scaffolding that you need. I also need to switch the target over to the simulator for testing. It's much faster than pushing changes to my device. So I normally start by just compiling the project to make sure it runs. I know that before I change anything, the project will execute. So you'll notice when it does that, it validates the code. And then the simulator starts up. That's a really good sign. Now I'll start up Claude Code through Cursor and get it to write my application. I start by telling Claude Code to initialize. In other words, go through the logic that's already been created and make sense of it. Claude loads these details about the project structure into memory, which can then use later to write the code. Now, for the sake of time, I'm going to speed up certain parts of this. Claude spent a lot of time thinking, so I'm going to focus on the important bits and just fast forward the rest. Great, so now I'm telling Claude Code to enter plan mode and build me a Vision Pro application that allows me to select a file, estimate the depth using AI, merge that depth information into the photo, and display it as a spatial image. Now, to make things easier, I'm also going to ask to add a button that just displays a preloaded JPEG. This just saves me the time of going to pick a file every time. This is a picture of me hiking in the Daintree rainforest in North Queensland. I chose this image because it has good separation of depth between the foreground and the background, so we should get a really good 3D effect. Once it's done, I'd also get Claude to design unit tests and build the documentation early. I think this is really important to do up front because both testing and documentation become exponentially harder the later you start. So I think it's always best to get in early while things are simple. Now that's done, let's run it and see the results in the simulator. What we see now is two images side by side. The first is my original JPEG photo, and the second is a black and white image that's been generated by AI. What's happened here is that I've pushed that photo into Apple CoreML framework and asked it to predict the depth information using a standard depth prediction model. White indicates that the pixel is close and black indicates that it's far away. So now let's press the button and see what it generated. Okay, the image is upside down, so we're going to need to flip that. Right, so now the image is correct, but the depth mapping information is upside down, so I'm going to need to flip that too. Let's take another look. Okay, that looks great. So now I'll update the documentation and push this up to the Git repository. Then I'll change my target to run on my Vision Pro device and head outside to see what it looks like. So there we go, a spatial image. Now, obviously you're watching this on a 2D device, so you don't get the same effect as what I see. But if I move around the image, you'll see how the effect is achieved. Now, with a bit more time, I would have introduced some feathering and smoothing and perhaps even run a second pass over the background to create a little bit more depth. This is by no means a finished application, but what I've achieved in an hour is absolutely unbelievable. So let's step back now and think about what just happened. In under an hour, I built an application that takes a flat photograph and turns it into something that you can look into. That's not a gimmick, that's something genuinely new. And if you've used the Vision Pro, you know how powerful the spatial images really are. They really bring depth and feelings to photographs when you see them in 3 dimensions. And this is exactly what I've been talking about in this series. Apple's advantage isn't in making AI models. Plenty of people are doing that. Apple's advantage is the way they've built the entire stack, the hardware, the software, and the frameworks, all designed to work together for AI. CoreML doesn't just run AI, it runs AI fast on device without needing a data center or internet connection. And that's because Apple controls the silicon. The neural engine in the chips was purpose designed for exactly this kind of workload. And what that means for developers is the barrier for entry has collapsed. 5 years ago, building something like that would have taken a team of specialists months. Today, a single developer with the right tools can prototype it in just an hour. And that's the shift that Apple has unlocked. And as you can see, it's only just getting started.